So good afternoon, everyone. It's Bill Simpson here on behalf of TechStar and Magnetrol International with Erwin Brocato. We are going to make a presentation that we are now calling Avoid Price versus Performance Pitfall. The premise idea that we came up with this, I did it, it's about the fourth time we've done it. Erwin and I came up with the slides. It's the idea that not all process applications were created equal. That I just had a recent example. I was working at a peaking station where they were burning #2 fuel oil as the fuel, and they were basically, when the turbine would go offline, they'd shut it down. The oil that was unspent would go into a sump, into a pit, and it would then become a hazardous waste. Even though there was nothing wrong with the oil, that oil lost its value. On the tank side, where we were measuring level, on the big tank, the 1-million-gallon tank, that oil is an asset to the company. But once it goes through the turbine, it gets spit out, and it winds up going down into the sump. It becomes waste oil, a hazardous waste that they have to treat, a liability. Those two applications for measuring the level in the sump and the tank are not equal. That there's value on the fuel side, and it's a waste product on the sump side. So the idea is we want to have different levels of technology that we could throw at measuring the level in the tank, measuring the level at the sump. That's just one example I could think of. Anyway, for a number of years, hopefully, Magnetrol has been providing and developing instruments in order to change our customers' experience by providing flexible, reliable, and feature-rich level technologies, but at the same time offer them at different cost tiers. So basically, okay, let's see if this, don't have control of my presentation all of a sudden. It won't go to the next screen. Oh, here we go. All right, here we go. So here I'll introduce myself. So I've been in the business for 40 years. Prior to Magnetrol, I worked for Honeywell for about 10 years and ABB for 5 years prior to Magnetrol, and then I was in the Honeywell distribution side. So I've been a total of 40 years. I've been in both controls, data acquisition, and instrumentation in the past. So the overview of what we're going to cover, we initially had titled it The Right Chemistry for Level Control, and then Avoid the Price versus Performance Pitfall. But what we're going to go over today is 4 products. The new Eclipse 700 guided wave radar that we just released, an R82 through air pulse burst radar level transmitter that's a low cost with high performance, a lower cost magnetic level indicator that we call our Orion vector, and then we're going to also show EchoTel ultrasonic contact switches for a unique application idea that we could use these directly as level controllers, that they would, a low-cost solution. So the first 3 instances of the first 3 products discussing lower cost continuous level measurements, and the EchoTel switches is talking about using contact switches for level control. So it's just an alternative to regulatory continuous control. So these are the topics. All right, so we'll start with the guided wave radar. Erwin, are you able to show them? Are you showing them the 700 on the on your camera? I'll assume that you are. And okay, so this product is a brand new product that we just came out with last year. It has tremendous success. I personally had one application where I sold 70 of them recently, and they worked very well. The 700 is at a price point that we're making it so that it can work on commercial applications, but we're not compromising. We're mentioning it without the bells and whistles included in our premier guided wave radar, the model 706. But what I'm going to show you, my job is to show you that the 700 is not a stripped down OEM model, that it basically has all the 706 performance. So if I tell you that the 706 can measure within 0.1 inch, so can the 700. It also is a Heart 7 device, so it has the latest and greatest Heart tools for communication the DTM, the DDEs, the device drivers, everything about it is Part 7 compliant. Sill 2 and Sill 3 certified. It can be with a 93% safe failure fraction. The way we were able to introduce a new product with that safe failure fraction and the Sill 2 certification is that we were able to transport the hours of installation and I guess the months and years of installation that we had with the 706 because we designed the 700 on the 706 software and firmware platform. So virtually we took the firmware of the 706 transfer or transmitter and transferred it into the 700. It is identical. The performance is identical. What we've done to get the cost out of the product is change the form factor of the unit. We're going to show it to you with the video camera that Erwin has at TechStar. But right now, the first thing I'm going to mention is that it has the single compartment housing is one area where we were able to get the cost out of it.
That's right here.
Waiting for this to come up next. Then we basically, the next way that we're getting cost out of it is we're limiting the permutations of probes that are available. And also that the probe design is fixed, that we are only going to offer it in coaxial and in both a standard rod, a single rod, and with a flexible cable. And basically by doing that, we're only going to limit the choices. We're going to limit the choices of the permutations, like I said, of the probe types, and that the probe is fixed into the housing so that there's no expensive coupling between the probe and the housing. Also, we're also going to limit with the permutations up to 400 degrees Fahrenheit and up to 6250 PSI. So you don't have any of the exotic high pressure, high temperature steam probes and gas application probes listed. 400 degrees Fahrenheit. Just to put it as a reference, a 250-pound boiler, like a Cleaver Brooks boiler, for example, can go up to 250 pounds, which translates to about 406 degrees Fahrenheit. So basically anything from package boilers, deaerators, any of your very, very common applications, the 700 is ideally suited for that. So as I mentioned, there's no steam or high temperature, high pressure application probes or no segmented probes. There were going to be no specials. That's another way we're getting cost out of it, that it's going to be a cookie cutter design with no specials offered. So we're going to have it available for quick delivery. And by that, I mean a few days. If you can get it in 5 days delivery, right? Simplified probe mounting, I mentioned already. And I wanted to also, before I go past the next part, I also wanted to mention that up to 400 degrees Fahrenheit, but we offer it with a lot of different choices of O-ring seals. So that if you had an ammonia, a refrigerated ammonia application where we know the ammonia molecule is very small, glass is the best O-ring material. A solid glass O-ring is the best material to seal off those little molecules from getting up into the housing. Anyway, we have multiple choices of O-ring materials for the different chemicals that you would use it for the suitability. Let me talk about the features. It's all the 706 features. We have 9 common tank shapes for the volumetric output. So if you want to extrapolate volume from the level measurement, we can help you there. We also have a 30-point custom strapping table for uncommonly shaped tanks, also for changing level to volume. We've got it available for cryogenic applications. As I mentioned before, the probe designs up to 400 to 6250 PSI, and we have the Sill certification. So why do I refer to it as a multivariable? Well, I just said it. The transmitter, because it has the 706 firmware, could be used for a volumetric, a flow application, an interface application, not just level. The other thing, the level measurement, it is a true level measurement. So here it is priced at the same performance as a differential pressure transmitter, like one of the higher quality ones, less than actually. And basically, instead of it being an inferential measurement, it's a direct level measurement. It's actually measuring the distance to the surface of the level to the bottom of the probe. And therefore, it's not being an inferential measurement, but a true measurement. And this true level is overfill capable. With that coaxial probe that you see pictured in right there, that basically means that you can measure right up to the top of the probe, right up to the thread engagement, all the way up to the seal. We have the 4-button keypad and a graphical LCD display. The display is so good that you can actually see the echo curve the same way you could as if you were using it with heart and using a computer. And I will also say to you this, that if you know the 706 hierarchy of the configuration hierarchy, you will absolutely know the 700 because they're the same exact menu tree. Proactive diagnostics, you have a dry probe, you have a problem with the end of probe, or if you have some lost signal, all the same things that you get with the industry leading 706, you get the same diagnostics with the 700. So here you go. I want to just reiterate the single compartment die cast aluminum housing is one of the areas we got the cost out. The fact that the probe is integral to the transmitter, and also, unlike most of our competitors, Magnetrol makes our electronics in-house. So we have control of the protection, and we protected the electronics against moisture, vibration, and physical damage. And I should add, with doing that and the fact that we make it in-house, the probes that we ship in America are primarily built in the United States. So we should all be very proud that we have an American-made product here. All right, so here's one of the limitations, or a couple of limitations. We don't want this probe, you know, as I said, it's more for the commercial and the light duty applications. So it's only available in intrinsically safe and non-incendive. So you don't have the explosion proof options in this enclosure, right? So you've got the equivalent, like the non-incendive rating, class 1 div 2, class 3 division 2, class 1 div 2, and you have intrinsically safe. So you would wire that with an intrinsically safe barrier. So if you have, let's say you're in a food and beverage application and you're using it on something that has some chemicals with alcohol and a low flash point, you could either wire it intrinsically safe, or you could wire it class 1 div 2 non-incendive, but you're not going to have the explosion proof rating. We don't see that in that market. So just wanted you to be sure on that. Okay. That's one of the differences. So let's summarize. General purpose, it's available. It's available in intrinsically safe class 1 div 1, where you'd use a barrier, and then non-incendive class 1 div 2. So before I turn over the reins to Erwin, I just wanted to give you an idea of the price point, because it isn't an economical choice unless I can explain it to you, right? So we released it in April of 2020 with tremendous success so far. And just to give you an idea, with a 6-foot probe, a rigid single rod probe, and the transmitter complete with general purpose, it's $1,175. And I've sold differential pressure transmitters all my life for 37 or 40 years. And the list price is nowhere near that of a quality DP transmitter right now. And that's not including the 3-valve manifold that you would need, or the plumbing. So $1,175 is the list price for the example that I gave you. So Erwin, I'm going to stop sharing my screen and I'm going to turn it over to you.
Thank you, Bill. I do want to show the fact that this is the 700 radar, and you can see that it's a single compartment, like Mr. Bill was saying, and you cannot detach the probe versus our higher end model, which is the 706, that you do have the explosion proof dual compartment housing and a separate probe from it. So, like Bill was saying, we got rid of some of the iterations of the different possibilities in order to have a more cost competitive product that can be better suited for certain applications in the market.
Erwin, to that point, like the single compartment housing, right? So if you have something like, say, like ammonia gas or something that and this is very suited for ammonia refrigeration applications.
Yes.
You might need a secondary seal. So there's only one seal in the 700 to stop it, but you could add a seal to the conduit. Adelet and Kraus-Heinz and companies like that make a secondary seal that you can put in the conduit, so that if the transmitter did fail, the ammonia wouldn't back up into the wiring in the conduit. So that's all I have, Erwin. That's
Good.
all I have, Erwin.
Good. All right, thank you very much. Thank you. So I'm Erwin Brocato. I do not have as much experience as Bill, but I've been working with Magnetrol for about 12 years now. Well, instrumentation 12 years, Magnetrol about 4 years now. And I'm going to talk about the non-contact radar, our economical non-contact radar, the R82 26 gigahertz pulsed version of the radar product. As you can see here, just like the 700, we have fewer options for this particular unit. We do have a higher end model, of course, 2 different higher end models, 6 gigahertz and another 26 gigahertz. But this is one of my favorite devices because I used to be the regional manager for Mexico, and I used to sell a ton of these little devices in different applications. And I actually have a couple different pictures for installations on these particular devices. So it's a great performance unit that we were going to replace ultrasonic transmitters with, and the price point on this device is very close to what a ultrasonic device would cost you as well. You can see 2 devices on here. Let me go back to that one. These are the 2 options, right, that we have with the extended probe if you have an extended nozzle, and the shorter probe, which is just going into an open tank or perhaps like just a small nozzle at the top of a vessel. The different components of the device: 24 volts loop powered device, obviously going back to PLC. Here's your voltage. There is obviously a minimum always with the voltage on these devices, otherwise they go to fault. Lexan. So whenever you get the Lexan compartment for this device, it's not going to be an explosion-proof device, obviously, because it's a plastic, but it can be for a general purpose area or for just like an intrinsically safe area if you wire it up with the barrier. If you need an explosion-proof housing, you need to get the cast aluminum for the Class 1 Div 1. Then your antenna, again, minimizing options in order to get the cost down. We only have polypropylene or Tefzel options for this device. And the antennas, again, like you saw in the previous image, it's only the extended one or the shorter one. We can do them flanged. This device does have the option of having a flanged connection. That is a special though, and it kind of, well, it adds to the lead time as well. Here, and by the way, here are the different connections. We'll do it at the end. We'll do questions at the end. Yeah. Oh yeah. 10-4. So another cool thing about these, they can be used for sanitary applications, and what I mean by that is any kind of like a pharmaceutical or food and beverage application, because you do have the tri-clamp quick disconnect connection for these devices as well. That's another option that we can provide. We can provide a polymer flange as well if something like that is needed. There is a limit on the range of the device. Obviously, it is the lower cost model, so we can only probably go about, I want to say 40 feet with this device, which sounds like a lot, but the other ones can go up to 100 feet, right, the higher end models. So there are some limitations to this particular product. There's limitations obviously on temperature. 200 Fahrenheit is the max. Limitations on pressure. We can go up to 200 PSI on the device. So that's another limitation. On the higher end models, you can go up to, much higher pressures, obviously. So this is a very simple device for simple applications, low cost device. Accuracy is still pretty good at 5 millimeters. And of course, the dielectric constants, we can hit even very, very low dielectrics with this particular device. So if you're measuring some kind of low conductivity product, like an oil or some kind of hydrocarbon, it still has the performance of the higher end models, but it's just a more limited scope of what it can do. Approval is not a whole lot to talk about here. Like I said before, you have the explosion-proof version with the aluminum housing, which is similar to what you see here, what I'm showing here on the camera. Or if you're in a general purpose area and you want to cut costs even more, we can go to that Lexan, which is just a polymer cover as well. This is the device, how it looks like. I don't have one with me today, unfortunately, but this is what the display looks like. 4-button display. This is kind of a more simplified design than the higher end models that they have the full graphics display where you can do echo curves and all like that. You can still do echo curves through the DTM, through a laptop or some kind of handheld communicator with this device. However, on the screen itself, it's a little bit more limited. It's still not, I've configured some of these myself in the field, and it's not really that difficult. You got to learn how to use the DTM, but it isn't that hard at all to configure these devices. We also have, by the way, since we are joining today from TechStar, we have our local rep here in Texas, which is TechStar. They can also help you set up the devices if you are here locally in the area. They have a great team that is able to do that if you don't want to mess with configuring the device. This is, I guess, a cross-section of how the device looks like on the inside. There's an interior horn. That horn is about a 1.5-inch horn, but it's protected by the Teflon or polypropylene cover. And the cover itself is actually pretty advantageous because in a lot of these radar applications, you'll have any kind of condensation coming up, and accumulating on that Teflon rod or antenna. And the good thing about the design of this particular device is that that will all just trickle out or just drop off. Whereas with an ultrasonic, it would accumulate on the sensor and then it attenuates the signal because it is a sound-based device and it won't work correctly. Another problem with ultrasonics is steam. Any kind of steam in the process usually is very problematic for the ultrasonic wave to just go through that ultrasonic wave. With this is a radar, so we're talking about a electromagnetic pulsed radar. It will cut right through that steam. It won't be an issue. Also for vacuums, if you're working in a vacuum, obviously ultrasonic is not going to work because sound doesn't travel through a vacuum, but the radar will work. Whenever you're talking about radars and setting radars up, you have to consider three main things, which is the distance that you want to shoot through. So if you have a tank that's a certain amount of height, you got to tell us about that height. You also have to let us know the dielectric constant of the liquid. If you do not know what a dielectric is, or if you do not know the dielectric of the liquid, you can just Google. Most of these are online already. And of course, the disturbances in the process. So if you have any kind of agitation, if you got agitators, if you got foaming in the process or rapid movement up and down in the tank, that's something that we need to know to set up the device correctly whenever we're installing it. Obviously, there's going to be different limitations for the different products. In this chart that you guys can see here on the presentation, on the right, it'll tell you how far the unit can go based on the different disturbances and dielectrics of the products. If you have water, which is dielectric of 80, way at the bottom, and there's no disturbances, you can go up to 40 feet, no problem, you get a good reflection. But if you have maybe like a crude service and you have heavy agitation, you can only go down to 7 feet. You can't really hit that product as well with this device. Now, again, we have a higher end model that could probably do it a little bit better if you have those conditions. So this is for easier services, let's say, for this particular product. Temperature and pressure ratings, I kind of mentioned them already. 200 PSI at 200 F is the max for this device. So there are limitations, but again, we're trying to cut the cost out of this product. And one of the ways that you do that is to limit the amount of configurations that you will have in the device. Installation, again, it's very important. I'm not going to talk too much about this because whenever you order this particular device or whenever you're going to install this device, you always need the factory to know how you're going to install it, what's the size and geometry of your tank. Again, we can send a service guy out there, or our friends at TechStar can send a service guy out there. But we do need to know all these geometries of tanks, whether it's a cylinder, where is it a bullet tank, where are you going to install the radar within the actual tank? Are there any obstructions? Are there ladders? Are there chains? Are there agitators? Are there stirrers, mixers, serpentines inside of the vessel? All that stuff we need to know because it will matter, because unlike the guided wave radar where you have your conductor, right, and your electromagnetic signal travels through the conductor, with the non-contact radar, it's going through air. So anything around that beam might hit that beam and reflect back and be detected as an echo. Now we can eliminate that false echoes, we call them, through the software. It can be done, but it takes a little bit of time to set that up. But so I guess in conclusion for this particular slide, we need to know the dimensions of the tank and if there's anything inside of the tank that could be in the way. List price for one of these. Okay, price point $999. which for a radar is a phenomenal price. It's almost at the ultrasonic price. And I believe this is the list price for an aluminum housing. So I think the Lexan may go down a little bit more. Correct me if I'm wrong, Bill, but that is, I believe that is the lowest price. Is he on? Bill, can you hear us?
Erwin, I had myself muted because my grandkids were screaming.
No worries, buddy. No worries. Just the price point.
You're absolutely correct. The
Okay.
Lexan is less expensive.
Excellent. Excellent. Thank you.
Lexan, yes. So that's how I priced it.
Awesome, my man. I appreciate it. Thank you, sir.
Thank you.
All right, so now we're moving on to something that it falls under instrumentation sometimes. Sometimes it does not. It falls under like mechanical products inside of a facility, kind of like with a valve or a sight glass. These are the magnetic level indicators that you can see here. Actually, before we go that, can we show you the picture of the foam? Or actually the video would be great if you can show the video. Yes. This is an example. This is a great example of, hopefully you can see this. This is a great example of one of these R82 devices in a sugar factory. This is in Mexico. So you can see all the turbulence, all the disturbances. You can see steam coming up. You can see foam. You can see there's actually a stream of liquid that can maybe be picked up by the device as an echo or as a level. So our representative down in Mexico, you know, they were really good, and they set up this device, and it's functioning very, very well. So again, you know, to Bill's point, great performance at a low cost. It's actually a pretty good solution for this kind of application. Good. Thank you. All right, so moving on to magnetic level indicators. Low-cost magnetic level indicators. Well, basically magnetic level indicators, we're going to try to replace your common sight glass. I think I was talking about this before. It may fall under the mechanical component in a facility, but if you have a sight glass, any kind of tubular sight glass or reinforced sight glass, that could be a safety hazard. It may be a device that could be compromised by somebody hitting it, or over time the glass deteriorates, or something can happen and you have a steam leak or some kind of leak of a product, and you do not want to have a leak of something that's toxic or lethal, or high pressure steam, obviously. So magnetic level indicators basically replace these kinds of sight glasses, and we offer a higher safety product, also a product that requires less maintenance than a lot of these sight glasses, because you don't have to replace the actual glasses over time. So there's an advantage to these MLIs, the magnetic level indicators. So on the low cost side for the magnetic level indicators, we have the Vector. The Vector, all it is, it's a brand name. We have different brand names for our different products. The other one you see on here is the Atlas. That's the higher end model. So the Vector is going to have, again, certain limitants, not as many variations, a simpler flag rail indicator versus our Atlas indicator. We're also going to use carbon steel for a lot of the process connections. We're also going to try to eliminate flanges wherever we can and just use NPT connections in order to bring that cost down for this particular product. But still a high quality product. The float that goes inside of this product is going to be as good as a float that would go into an Atlas product. But again, we have limitations on what the device can withstand as far as pressure and temperature as well, just like the other products that we've been talking about. Less configurations, no specials, but same quality, lower cost. The only thing that I would mention is that we can also, and I'll show a little bit on the camera here later, that we can do level switches and level transmitters on these devices as well. This is perfect for like a wastewater treatment facility. OEMs might buy some of these, or some kind of chemical storage where you just need a simple device to indicate level. You may not need a transmitter. You might just need a local indicator, and you don't want to deal with a sight glass, because if the sight glass breaks, you might have a spill, and you don't want to be replacing sight glasses. Or you might not you can't probably even see the level. And I'll show you another image that I have after here that's pretty good. That it shows you why we want one of these instead of a sight glass. Okay. So the limitants, or I guess the simplifications to the device versus our other models. So obviously less configuration. So no B31.1 construction, no B31.3 construction. Those are the construction and piping codes that are required for process in a refinery, which is B31.3, and power piping, they call it, which is B31.1. B31.1, all that means is if you connect it to an auxiliary tank that's connected to a boiler, you have to meet certain requirements when you're building and when you're welding chambers or pressure vessels. And we don't have that for this particular device. So you can't put it on a boiler system, and you cannot put it in a refinery. So that's one of the limitations. 2-inch chamber, you can get it just like with the Model T. You can get it in any diameter you want as long as it's 2 inches. So what does that mean? It means that you can only fit a 2-inch float inside of the device, which is limited to certain specific gravity ranges. You can't go too low on the specific gravity. Standard plastic flags. These are the flag railings. The ones that are in here, this is for my demo. This is going to be a metal flag, but we're going to try to standardize with plastic flags. We can bump it up to metal flags. It's going to be a little bit more as far as cost, but you might be in a situation where you prefer a metal flag, or you've been specifying these devices for years and you want a metal flag. We'll give you a metal flag as well. Limit on the flanges. Low pressure for these devices. We cannot go beyond 300-pound flanges. Same thing with the pressure. 740 psi at room temperature is the limitant on a 300-pound flange. And then the temperature, 500 F. It's actually a pretty reasonable temperature for one of these devices. And in that case, we're also going to use insulation blankets on the devices on those high temperatures. I'm just going to show it here a little bit, and y'all can see that. That's the insulation blanket on the device. Oh, it's over here. So we're not using the other camera. Good. Aluminum indicator with polycarbonate window. Actually, the window is polycarbonate. This is what it looks like here, and I will show you how that all works at the end. 0.55 SG minimum. If you have a very light end hydrocarbon, this device is not going to cover it, but actually 0.55 is a pretty reasonable specific gravity. If you don't know what specific gravity is, it's the relative weight of a liquid versus water. So you just take the density of a liquid, you divide it by the density of water, which is 1 or 0.99, and you get your SG. So usually oil is around anywhere from 0.7 to maybe a 0.8 or something like that. Diesel is usually 0.8 as well. And the lower and the lighter the hydrocarbon, the lower the density, and this may not be the product for that particular application. But again, if it's just for something like strong base, those are going to have really high specific gravities. Water's 1, and a strong base is going to be maybe a 1.1 or 1.2. Measuring spans, says it right there, 212 inches is the max. That's actually pretty reasonable for one of these devices. And limited configurations, no specials. We try to simplify the device as much as possible to keep the cost low. We are able to do simple controls with level switches on the side of the device. So this is the chamber of the device. You're going to mount a level switch on the side, and it can do a simple control, just an on and off switch. But if you stagger multiple switches on the chamber, it can maybe turn a pump on or off. In that case, we would use the blue item that you see on this presentation because it's a higher rated device. That's a 10 amp switch, and if you want to start a pump, you need a lot of amperage, and that you're going to use that blue switch. And to stop it, you're also going to use the OES switch. But they all work off the magnetic level of the float that you can see here as well. Okay, good. All right. And you can also do transmitters on these devices. That is obviously a little bit more expensive. This is just the probe of a Jupiter transmitter that you can see here. Can you see it on the other one? Okay, good. This is the probe, but it's connected to a transmitter. That transmitter is a 4 to 20 device. It's a little bit more expensive, but if you need a control on the device besides just the local indicator, you can do it with switches or with a transmitter connected to a PLC. We can also provide you with a controller, or we wouldn't because we don't make controllers, but our local representatives carry controller lines, and they can hook it up to the device so they can power it, and it can give you a local indicator as well. Blankets, they're all hand sewn in our factory. And Bill mentioned already that these are all made in the US. So all the Orion stuff that you see here, all this is made in Baton Rouge, Louisiana. The blankets are hand sewn over there as well for high temperature and protection for personnel. So if you have a high temperature application and you don't want anybody to get burned, I highly recommend getting an insulation blanket as well. We're also, if the temperature exceeds, I believe it's 250, we're going to put the insulation pad behind the indicator so it protects the indicator as well. Typically in that case, if it's just like 250, we're not going to do the blanket. We may not even do the blanket a lot of times if you guys don't need it. Okay? But I recommend it for protection of personnel. Did I hit something? Yeah. There we go. One more accessory on these guys. And if you get into the case of an older vessel and you're connected to an older vessel, those are going to typically have corrosion inside of the tank. And that corrosion may accumulate on the magnets of the float, as you can see here, because they're ferromagnetic. So most tanks are carbon steel. And if they corrode, those filaments will stick to the float, weighing it down over time. So one of the solutions for that is what we call the magnetic particle trap, where you can see in the image right there, which is just a spool piece with a magnet inside of the spool piece that pretty much captures all that sediment, I like to call it, or filaments, over time. And you can open up the actual spool piece and take out the magnet and wipe it down. And that will prevent accumulation of the particles on the actual float. You only need one at the bottom process connection. You need to spool the top connection, of course, but you don't really need another mag trap on the top. You only need one at the bottom. Usually that's more than sufficient. And this is the picture that I was talking to you about earlier in the presentation. This is the one where, you know, I was talking about MLIs and their safety considerations and the fact that you don't have to give as much maintenance to the device, but you know, it also, you can actually see the level, which is great. A lot of times with the sight glasses, you can't see the level. So this is a perfect image. This is a power plant, I think somewhere in Tennessee. And we swapped them all out. We had a small project, and we put magnetic level indicators on those devices, and there you go. You know, much better. You can actually see it, which is the main, not the main thrust of this device. I think safety is more important, but the actual capability of actually seeing the device is a big game changer versus a sight glass. Okay, and now pricing, simple vector, 2 feet. We're looking at $1,300. Okay, so that's a very, very reasonable price. This is a stainless steel device, obviously. We're going to keep it simple. We're going to have MPT connections, carbon steel at the top and the bottom for the caps. That's a pretty good price for one of these devices. It's very, very competitive. It's competitive with a lot of low-cost manufacturers, for sure, because I've had that situation, you know, overseas where you do a lot of business in Latin America where you need low-cost devices. This is a very competitive price. Okay, and now moving on, we're going to talk about the level switches, the ultrasonic level switches. You can just show these devices here with the gap switch for controls, and move all this stuff on the side. Okay, so you can see the gap. This is, well, let's go through the slide so you can see how this stuff works. So I think Bill alluded it to, at the beginning. You know, we've had a couple different transmitters. This is a point level device, but you can actually do some controls with this device. High level, low level combination of control, pump on and off. It's actually a very common device to control levels. I've seen it in all kinds of applications, sumps, underground tanks, seal pots, just a variety of different applications that you can target with this device. Basically all it is, it's a switch that cares if the probe, the gap that you can see on this image here, is wet or dry. That's all it cares about. It doesn't care about dielectric constants. It doesn't care about changes in specific gravity. It can be a low specific gravity. It can be a high specific. It doesn't. None of that matters. The only thing that matters is if that probe is full with liquid and the ultrasonic signal can transmit in between the transmitter and receiver, your switch, the relay will be energized. So that can be a high level switch. So if the level comes up to the sensor, to the gap, let's say the switch is installed sideways, the level comes up to here, it'll close the gap and the relay will energize. Or vice versa, you can set one of the little jumpers on here for a low level switch. So it's the relay is always energized because the tank is full. But if that level drops below the gap is now dry and it will energize the relay on the particular application. So that's how that one works. For controls, you can have one or two switches. The 961 is just a single gap. It just gives you a one relay contact. Oh, another thing I do need to mention about these devices is that they do have, if you get the relay version, you get the malfunction relay, so you can actually, if the device were to fail, the malfunction relay will trip. Let's say that you got a short on the board, or if there's something wrong with the sensor at the bottom of the switch, if something shorts out, the malfunction relay will trip and it will tell you if it's not working. So that's, or self-diagnostics device, which is kind of a smart device versus the old school mechanical switches that you had to actually go out there and yank a lever to make sure that it's still working. With this device, if it stops working, it will tell you. If the board's shorted, it will tell you that the board or that the switch is no longer working and you need to get either a new board or just a new device. So the 961 is the one that you see here or on the screen on the left. That is the single point device, high level, low level. And we have the 962, which is two independent switches. It's got two gaps on the rod, as you can see, obviously. One relay for the low level, one relay for the high level, or it can be a high, 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 or a low and low, low. So, or it can be a pump, start, on and on device as well. You do have to power this device. It is 24 volts DC. It can be 110 AC as well. Again, the output is relay output, unless you get the analog version, the loop powered version, which is just, it won't have any relays. It's just going to output a certain milliamp output to your controller. Standard is going to be 8 milliamps. If it hits a level, it switches to 12 milliamps. If you get the 962, the second level is 16 milliamps. And you also have a fault. But instead of being a relay fault, you just have a 22 milliamp fault or 3.6 if you set it to up to 3.6. And the settings are super simple. It's literally just a jump around the device to set the fail points. Fail high or fail low. This is the installation, how you can install them. For controls, you can do, like I said before, a low level, high level alarm like you see on the left here, or you can do a 962 on the opposite side here on the right. Your low and high level all in one device, which is pretty cool. That way you don't have to have multiple taps to the tank. You just insert it from the top and then you can do your controlling. Also, another interesting thing that you can do with this device, you can kind of simulate a flow switch. We have a flow switch actually, but in a certain diameter pipe, if your level goes below a certain point, that means it could be a low flow condition, and this switch can detect a low level on the pipe that is proportional to a low flow, so you can put it before a pump so you can protect your pump from cavitating, or it'll at least turn the pump off if it begins to cavitate because you have a low flow condition. So that's another pretty cool little application that you can do. Obviously we have flow switches, those are better, but they're not part of this presentation. Sill rating for this device, very important. If you want a Sill rated device at a low cost, this is the way to go. I already talked about the self-diagnostic and the self-test features. Different probes, if you want a really low-cost probe, we can do a polymer probe. The one that you see here is stainless steel, but we can do a polymer. I believe we do CPVC. So it's even lower cost. So if you like a strong base or an acid or anything like that, and you do not want to use Monel or Hastelloy, we can go down to the CPVC or Kynar if the temperatures and pressures permit the use of a polymer. Then again, and the remote electronics and the time delay as well. Another just little features of the device that can be used in the field. Here's what it looks like. This is the relay version. Everything I was talking about over here, you got your malfunction relay. That's the red LED, when it goes to fault, it'll show you it's gone to fault. Wet means that the sensor is wet. Level, is if it detects the level. You got a time delay. You got a button to test the actual level as well, the level LED or the level relay, to make sure it's working before you actually install the device. A lot of these will come. A lot of Magnetrol ultrasonic switches sold in the market come without these features. It's the 910 device. We sell a lot through OEM, so you may have a device already like this from us that does not have all these features, so you can upgrade to 961 for a very reasonable price as well. Another thing, no calibration, no moving parts. If you have a mechanical switch, you have all these variables that can affect how the switch performs. If you have changes in its SG, changes in dielectric constant, all these things are completely eliminated from this switch. All it cares about is that gap full or not? That's it, with liquid. Now, I do want to talk about limitations before we go to price points. One of the limitations with this device, if you have a very viscous product, it's going to accumulate in the sensor, and then eventually there's going to be so much accumulation in there that it's going to think it's a level. So I do not recommend this product for highly viscous, like a molasses or honey or a very, very thick crude or anything like that. You do not want to use this product because it will not work correctly. Price points. The 1962, so this is a stainless steel probe, class 1 div 2, explosion proof, or this is div 1. No, div 2, explosion proof, $1,300. This is basically a control, okay? You can control your level for $1,300. That's a fairly reasonable price in my opinion. It's not a transmitter. It's not gonna give you any kind of trending feedback or anything like that. But you can do it just a very, very simple control with one instrument in that chamber or bridle. The 961, if you just want one high-level control or one low-level control of that liquid, you can get a controller for $700, which is this instrument. It's pretty good. And then finally, the 910, this is the one I was talking about that doesn't come with all the bells and whistles. It's just a basic switch with a relay. Comes usually from manufacturers. This one's about $500 for one of these devices. Very good price. So just to recap, talked about the 700, our newest product, low-cost device with a lot of the bells and whistles. To be honest with you, with the 706, the higher-end model, I mean it's the same. So it's the same engine, right? It's still a V12. The chassis is a little bit different. You don't have a Lambo chassis anymore. You have a Volvo maybe. But it's still pretty good device at a reasonable price. The non-contact R82, which I talked about as well, this is again similar to the 700. It's a little bit of an older product, but it has a lot of the good features and benefits of our higher end models for a lower cost. We got rid of all the different options and different configurations to get to that cost. Magnetic level indicators, they speak for themselves. They're a great replacement for the for the sight glass products, just because you can see the level, safety, critical issues as well, and less maintenance costs on the devices. And if you get the Vector, it's even at a lower cost. But the cost savings from maintenance itself could pay for this product over the course of the life of the product. And then simple control with level switches with our EcoTel product line as well. Okay. I don't know if there's any questions from anybody. So thank you. I mean, we have, if you guys have any questions on the chat or here locally, please make them.
I was going to say, I can't really think of any questions, but I appreciate learning about all this. We're all students at the local college, so this is valuable information.
Good. Okay. Good. No questions on the chat? No. I can't see there. Okay, good. All right, well, thank you very much, everyone. Bill, if you're still on, thank you very much as well.
Thank you for your time.
Thank you for your time. Have a good day.